Hi, my name is Timo and I'm very pleased to present our recent work in this video. For the manufacturing of miniature force torque sensors, extreme accuracy is required due to the tiny size of the strain gauges inside the sensors. The current method of manually assembling them by hand is difficult, time-intensive and error-prone. To improve this, a system to pick up the tiny objects from a plate and place them on elementary cells is being devised. There are three main contributions in our work. First, we propose a robotic system with extreme accuracy. Second, we evaluate different camera, lighting and object detection techniques. And third, we propose an end-to-end approach leading to an overall positioning accuracy of ±0.3 millimeters. A 6-axis robot is chosen for the kinematic system. The robot is equipped with a custom 3D printed end-effector comprising a suction gripper and 3 yellow markers for camera calibration. An advanced camera and lens, as well as lighting setup, turn out to be crucial to the quality and overall usability of the images. By placing the tiny objects on a semi-transparent plate with a lattice of LEDs underneath, the details of the strain gauges stand out very well. The paper focuses on the perception module by evaluating methods to obtain spatial information for 2D location and angle. Since the detection happens in a completely controlled industrial environment, image segmentation and blob detection are sufficient for the task at hand. Python is chosen as the primary programming language because of the huge array of libraries geared towards computer vision and scientific work. OpenCV is used for all image processing tasks. Finally, we present an end-to-end approach which integrates the perception module, camera to robot calibration, and a last-minute routine for correcting the component pickup position. The correction routine turns out to be a key success factor and leads to an overall positioning accuracy of ±0.3 millimeters. The algorithm proves itself very robust since it works not only for known components but even for household objects that were never considered during testing. In future work, we plan to turn to machine learning, which can work in even less than perfect lighting conditions. Improvements of the assembly machine are the manufacturing of a more precise end-effector out of aluminum and the replacement of the 6-axis robot with a linear Cartesian kinematic system. Thanks for your attention.